Now let's talk about how we can determine the heart rate from EKG. We can do this by finding out how much time passes between two QRS complexes. QRS complex represents a heartbeat. So the time between two QRS complexes can be used to calculate the heart rate. So the way this is done is by finding out how many big boxes are there between two QRS complexes. If we look carefully in the ECG, there are actually two types of boxes: big boxes and small boxes. 5 small boxes make up one big box. And since one small box represents 40 milliseconds of time, 5 small boxes represent 200 milliseconds. Hence, one big box is 200 milliseconds. Now with this, we can calculate the heart rate by finding how many milliseconds passes between each heartbeat. But the quick method to do this is using a formula. Heart rate equals to 300 divided by number of big boxes between two QRS complexes. For example, in this ECG, number of big boxes between two QRS complexes is 1, 2, 3 and around 3.5. So 300 divided by 3.5 is around 86. So the heart rate is 86 beats per minute. Normally, there should be 3 to 5 big boxes between two QRS complexes. Next, we are going to learn about is how to determine the ECG axis or the QRS axis. In order to understand this, we need to go back to this picture which shows the heart with its summation vector. Normally, the summation vector is directed downward and towards the right. Now, if we place a grid over the heart with 0 degree towards the right, plus 90 degree to the bottom, plus 180 degree to the left, and minus 90 degree to the top, and supposing that the heart is positioned normally and the electrical activities are being conducted normally, the QRS axis should fall between minus 30 degree to plus 90 degree. Means the summation vector should be present in this bottom right corner or just a little above it up to minus 30 degree. This is the normal QRS axis between minus 30 to plus 90 degree. If the axis does not fall between these numbers, then we call it as axis deviation. If it goes beyond minus 30 degree, let's say minus 40 or minus 50 degree, then we call it as left axis deviation, which can be seen in conditions like left bundle branch block or ventricular rhythm. Or if the ECG axis goes beyond plus 90 degree, say plus 95 or plus 100, then we call it as right axis deviation, which can be seen in right bundle branch block or right ventricular hypertrophy. To find out the QRS axis from the ECG, we need to first understand a few things. This is the grid to find out the QRS axis. Lead 1 views it from the 0 degree angle. This means any electrical activities moving towards 0 degree will produce a positive deflection in lead 1. Any electrical activities moving away from 0 degree will produce negative deflection in lead 1. And this is important, any electrical activities moving along the plus 90 degree angle will produce a flat line in lead 1 because it's moving perpendicular to 0 degree. Means it is moving neither towards nor away from 0 degree. So if the electrical signals are moving in a perpendicular way, then they won't produce any deflection in the ECG. One thing to take away from here is if QRS axis goes beyond plus 90 degree, then it would produce a negative deflection in lead 1. Similarly, lead 2 views this grid from plus 60 degree angle. So as I explained before, any signals moving towards this 60 degree would produce a positive deflection, and any signals moving away from it would produce a negative deflection in lead 2. And also, any electrical signals moving perpendicular to it would not produce any deflection. So if I were to draw a perpendicular line to lead 2, then it would be around here, that is at minus 30 degree. So to take away from here, just like in lead 1, if the QRS axis goes beyond minus 30 degree, then it would produce a negative deflection in lead 2. Let's recall and understand it carefully. Lead 1 views at 0 degree, and there will be a negative deflection if the QRS axis lies beyond plus 90 degree. Lead 2 views at plus 60 degree, and there will be a negative deflection if the QRS axis lies beyond minus 30 degree, because it is when the electrical signals start moving away from the lead. And if we recall, normal QRS axis lies between minus 30 to plus 90 degree. If it goes beyond plus 90 degree, it's called right axis deviation. This means if there is right axis deviation, then there will be a negative deflection in lead 1. Also, if the QRS axis lies beyond minus 30 degree, it's called left axis deviation. This means if there is left axis deviation, then there will be a negative deflection in lead 2. So for the QRS axis to lie within the normal limit, both the lead 1 and lead 2 should have positive deflection. Hence, these are the two leads that we need to watch out to find axis deviation. If there is right axis deviation, then there will be a negative deflection in lead 1. If there is left axis deviation, then there will be a negative deflection in lead 2. I have a short mnemonic for this. Just remember ROLT. So right axis deviation, watch out for lead 1. Left axis deviation, watch out for lead 2. This picture says everything. Both positive deflection, it's normal. Negative deflection in lead 2, left axis deviation. Negative deflection in lead 1, right axis deviation. Sometimes lead 2 might present as such, where it is partly upward and partly downward. This is called physiological left axis deviation, where the axis is between 0 to minus 30 degree. So it is within the normal limit but just slightly towards the left. But remember, before looking at these leads, always look for lead AVR. Lead AVR views heart from the right side, but since the electrical signals move to the left, the QRS complexes are always negative deflected in lead AVR. So if there is positive deflection of QRS complex in lead AVR, then it might suggest wrong placement of EKG leads. So that's it for this video. Thank you.